Audio Jungle. Audio Jungle.
All right, so 2 degree of freedom system, right? For the spring mass systems, we have to discuss 2 degree of freedom system. So here also, just like previously we had seen for 1 degree of freedom system. So there we had discussed forced vibration and free vibration. In fact, in free vibration, we had discussed damped and undamped. So similarly, we have for the 2 degree of freedom systems also. So this 2 degree of freedom system is basically here divided in two parts. Okay, it's divided in two parts. It is nothing but equation of motion for the force vibration. Okay, for the 2 degree of freedom we have a force vibration and we have free vibration. Analysis of undamped system of undamped system. So most of time in your examination this one they had asked. Okay, force also I think they had asked 1 or 2 times. I exactly I don't remember, but free vibration I'm sure question they had asked many times. Okay, why I'm saying for forced vibration, because forced vibration if you go for the calculations it will be lengthier. In fact, free vibration for 2 degree of freedom so much calculation we will have, but at least in case of free vibration it will be lesser than forced vibration calculation. Okay, so that's the reason they are asking free vibration undamped system for 2 degree of freedom systems. Now as already we had discussed, the system that requires two independent coordinates to describe their motion are called 2 degree of freedom systems. I already had discussed what is the degree of freedom for any system. So it is basically the coordinates. Okay, like how many independent coordinates required to describe the motion will be calling as a degree of freedom. Like if two independent coordinates required, like x1 and x2 requires to describe the motion, then it will be 2 degree of freedom. If it is only x1, then it will be for each mass, I'm saying for each mass, then it will be the 1 degree of freedom. Okay, so obviously if mass is what 1, then 1 displacement x will be there. If mass is what 2, then 2 two displacements required, x1 and x2. Based on that, now going for uh, the formula, which is very basic. If I say what is the number of degree of freedom, of the system of the system, then it will be number of masses in the system, number of masses in this system into number of possible types of motion, number of types of motion of each mass, of each mass. Okay, number of possible motion of each mass. Now I will show the diagram and you can identify in this way. See, suppose this is the system. Okay, and this system is what connected with the spring, and here we have a mass, then one more spring we have here. This is the another mass. Okay, now this is the system we have here, and obviously here we can connect like this, so it will be easy for you to understand the things like this. Okay, here this is what m1, this is what m2, this spring stiffness is k2, and this spring stiffness is k1. Here for this mass, the possible type of motion, here we can say this will be the x1, and here because this is the mass 2, so this is the mass displacement or distance x2. If you want to find what is the number of degree of freedom for this, it is single degree of freedom or first degree of freedom. So number of masses into the system, how many masses we have? 2. Now check number of possible types of motion of each. How many types of the motion? So obviously only one type of motion, and that motion is what? Only in x direction. That motion is what? Only in x direction. See, it can be x1, x2, x3. So but it is in x direction. So that motion is what? Only in one direction. Motion is what? In 1D, one dimension only, that is x. So number of possible types of motion of each mass. So each mass, if you check, this is also for m1 also only one motion in x direction, and for m2 also, so only one motion in x direction. So how many degree of freedom for this? If you check, so 2 into 1, and this is nothing but 2 degree of freedom systems. Similarly, we have a 3 masses system, and it is moving only in x direction. It is not moving in y direction or z direction. In 2 mass system we have, and this mechanism is in such a way that this motion will be in both direction, x and y direction. Then 2 into 2, it will be 4 degree of freedom. But here only one dimension you have for the system, for the motion, it is x direction. Hence 2 into 1, mass is what? 2, but the possible type of motion is what? Only 1. Hence 2 into 1, that is 2 degree of freedom. Okay, in this way you can identify. Like the same here also, you can draw in this way also, so meaning will be same. This is the mass m1, this is the mass m2. For this also check, this is what? x2, and this is what? x1, right? And here it can be spring, we can fix here. This is what? k3, this is k2, and this is what? k1. Here also if we'll find degree of freedom, so how many masses we have? 2. And what is the possible types of motion? It's 1 only. So what is the degree of freedom here? It's 3. All right.
Sir,
Yeah.
sir, 2, sir.
Sorry, degree of freedom will be 2 into 1, right? Suppose in the same cases, here one more mass is what added, then degree of freedom will be 3. So in that way you can find. So this is the formula you need to remember. Okay, this is what? 2. So this is the formula you
Sir, I
fix
have
in
one question actually. Sir, in this same figure, if I include one torsional spring in M1, then what will be the degree of freedom?
In M1 again, so one more motion will be added, that is the transverse motion. Yes or no? Transverse motion also will be added. So mass is what? 2, and one type of motion will be in x direction, and one more motion will be the transverse motion. So obviously degree of freedom will be increased in that way. You understood my point or not? That's the reason I find this formula, and this formula you
Yes,
need
sir.
to remember. Actually, the basic definition I had given, I had explained in when I started the vibration. That time I mentioned the independent coordinates required to describe the motion of the system called degree of freedom. That is also correct. Okay, but this is very perfect formula. In this way, you can calculate degree of freedom, and that time the answer will be correct, no doubt. Because if I say independent coordinates required, so might be in counting of independent coordinates you may wrong that sometimes, but if you remember this formula, then 100% your answer will be correct. All right, now we'll be going for the that 2D system, and here, as you know, if this we have a 2D system, 2 degree of freedom system. Okay, so definitely for 2 degree of freedom system, we have 2 normal modes of vibration, and each mode will have one natural frequencies. If we have 2 normal modes, then how many natural frequency we will have? 2 natural frequency. Why? Because this is 2 degree of freedom. Okay, so you need to remember, or you just write down this 2 degree of freedom. Here I will write 2 degree of freedom. So for 2 degree of freedom we will have 2 two normal modes vibration. Okay, and if we have a two normal modes of vibration, then how many natural frequency we will have? A two natural frequency we will have. Two natural frequency, and that two natural frequency is what? WN1 and WN2. Generally we will say it is W1 and W2. So in case of the 1 degree of or first degree of freedom, we had calculated one natural frequency. Now we will have a two natural frequency. All okay, two natural frequency. Why? Because it's a 2 degree of freedom. We require two independent coordinates here, x1 and x2, and for that we will have a two natural frequency, you can say. All right, now coming to the okay, not going so much deep detail because we have to finish, because 75% vibration is I have finished, so only 25% part. So what is the important thing that we will discuss? So directly we will go for the spring mass mechanism system. So we will go for the modeling. Modeling in the sense, we'll model one system and we'll show all the things. Like first we'll consider, okay, the force system and everything is there. Then as per our requirement, if it is free vibration, then force will make it equal to 0. So in only single formulation we can discuss everything. So we will take the case which is nothing but the equation of motion for the force vibration. Now we are going to find. So equation of motion, equation of motion for force vibration. Now for this analysis I am considering one system, and this is nothing but damped, viscously damped system. So I can consider damped 2 degree of freedom spring mass system. Spring mass system, I'll show you. So this is the system. Check. Okay. All right. Now the whole system I have to show you. All right. Okay. Now check. This is mass m1 and this is what? Mass m2. All right. Now we'll say the stiffness of this spring is nothing but k1. This is what? K2. This is what? K3. There is no hard and fast rule. You can take any k1, k2, k3, but in sequence if you take, it will be very easy for you for the calculation. And the damping coefficient for this is c1. This is what? C2. This is what? C3. All right. Now, like for the previous case also, I mean for the first degree of freedom also, we had drawn the free body diagram for the mass system. So similarly here also we'll do. So free body diagram, F free body diagram for the system we have to show.
Sir, we have to study for undamped.
Undamped will take here damper also I have used. If it is undamped, then I will make it equal to 0, C1, C2, C3. Don't worry, one by one will do. Okay.
Okay, sir.
This is the mass system. M1, M2. Okay, I will consider this is the force vibration. So I can say here the force is what? Obviously transient force, which is the function of time, F1, and here also force, because I'm considering force vibration, so F2 will be there, and it's a function of time. I had explained force vibration like F naught sine omega t or F naught cos omega t. Okay, and obviously for this mass, that displacement or you can say that coordinates x1, and here this coordinates will be x2. Two independent coordinates here we have. Okay, all right. Fine. Now I am considering force vibration initially. If it is free vibration, then F1, F2 will be 0. If it is undamped vibration, then C1, C2, C3 will be 0. Like that we have to consider. Now for this mass system, we will draw the free body diagram. So now you need to concentrate here. It's very important. See, if this mass system, the force direction you have to check. This is the force direction. Check carefully. This is the force direction. If the block is M1 is what moving in forward direction, then this spring K1, this K1 will be in tension. Yes or no? So I can say spring, I can write here spring K1, this is the K1 under tension. Under tension. So if tension means elongation in the spring, then what will be the this displacement? It will be positive. So you can take it is plus of x1. Why? Because tension we are getting in spring K1. Hence, obviously, positive displacement you will get, or you can say deformation or elongation you will get. So it is plus x1. Now we'll draw the free body diagram for this, because this mass is what moving in forward direction. So that spring force, which is called restoring force, will be working in opposite direction, and this value will be K1 x1. It is the restoring force. Damper is there, so damping force also it will try to resist the motion. So what will be the damping force? It will be C1 x1 dot. Already I have discussed in previous lectures what is the damping force, what is the restoring force, so no need to explain it again. Directly I am writing C1 x1 dot is nothing but damping force, and K1 x1 is nothing but restoring force, right? Now coming to this next, obviously that inertia force will be acting. So inertia force will be acting in forward direction. Okay, anyway, now we'll check this spring for the same. This spring also need to show you. See, this mass M2 is what moving in forward direction, because this force direction is this. So mass M2 is what moving in forward direction. So what about the spring K3? This spring K3 will be under compression, because this block is what moving in forward direction. So this spring K3 will be in compression. So need to write here spring K3. This is the spring K1, sorry, K1, and this is spring K3 under compression. Hence, that displacement or this deformation, which is nothing but x2. Okay, so spring K3 under compression, for this compression, for this spring, definitely, because it is going to short the length, so this x2 will be negative for this. Okay, x2 will be negative for this, so it's x2. Okay, now so this spring will draw the free body diagram. So free body diagram, this restoring, because it is going to compress, so this spring will try to resist the compression motion. So this will be the motion K3 into x2. This is the restoring force, and obviously damping force will be C3 into x2 dot. All right, so now same thing here you also do, because if you check for this spring K2, so this spring K2 will also be under under tension. Okay, why it will be under tension? Because this M1 is mass is what moving in forward direction, but M2 is also moving in forward direction. So overall impact over this spring K2 will be in tension. Okay, so spring K2, and for this if you draw the free body diagram, so that free body diagram will be something like this K2. Okay, and here it is nothing but it's a x2 minus x1. Okay, and similarly here this damping force, which is nothing but C2, it will be x2 dot minus x1 dot. And if you talk about the this force and this force will be same, yes or no? This force and this force will be same. So this is the free body diagram, and if you check that obviously that inertia force, so if you draw for this, so force is nothing but F1 here, and at the same time your displacement x1, and this is nothing but acceleration will be in x1 double dot is nothing but acceleration will be in forward direction. Similarly, if you check the force, that is called inertia force, basically mass into acceleration will be an inertia force, and this is what F2, and here this is nothing but x2 and inertia force x2 double dot. This is the free body diagram. Okay, this is the free body diagram. Now if you want to write the force for this, so you have to apply Newton's second law. Newton's second law of motion. To each of masses give the equation of motion. Okay, how many masses we have? Two masses, m1 and m2. So how many equation we will get? Two equation we will get. One equation we will get for the mass m1, and it will be the force will be F1, and second equation will give the will be for mass m2, and it will be equal to the all forces in free body diagram will be equal to the force, which is nothing but F2. Okay, that's summation of all internal force is equal to external force. All right, anyway, so now here we have to write for this free body diagram, again now check, I will write the application or as per Newton's second law, Newton's second law of motion, Newton's second law of motion of to each of masses gives the equation of motion. Equation of motion, right? Now how to write? So all the summation of the forces, take algebraic sum, positive negative, and put equal to F1. Similarly, we have to for the second mass free body diagram already we have. Based on this free body diagram, we have to write the summation of the forces is equal to F1 for M1, and summation of the forces for M2 is equal to summation of forces is equal to F2. We need to write. So if you write the equation, so directly I'm writing here, you just match the free body diagram, you will get it. Okay, so now the equation will be for mass m1. Okay, so it will be m1, that is the inertia force, m1 x1 double dot plus check c1 x1 plus c2 x2 dot, that is the damping force, minus c2 x2 this is x1, sorry, this is x1, You can check it, that free body diagram you can check, you will get this, plus k1 x1 plus k2 x1 minus k2 x2 is equal to f1. All the forces you can check from m1 x1 plus c1 x1 dot. So all the equation if you check, you may get it. Okay, now for this I can write, this is nothing but here, see, the summation of forces, algebraic sum. Okay, if the forces is what going in this direction, so you take it equal to positive and just opposite will be negative. In that way if you do, then you will able to write. Okay, any one direction you have to take. If it is you are taking this in this direction, all the forces positive, so take this one, and in this direction if you are taking all the forces negative, then you add accordingly. Okay, so you will get this equation. It's very easy, so you can check this. This is equation number 1. Similarly we can write for, because process is lengthy, so better I have to go fast. Okay, so for the mass m2, if we'll write, then again the same thing we have to repeat. Check the free body diagram, and there I had written m2 x2 double dash double dot minus c2 x1 plus c2 x2 dot plus c3 x2 dot k2 x1 k2 x2 plus k3 x3 is equal to f2. This is the second equation. This is the only equation. If we'll solve this equation, then our problem will be solved. All right, our problem will be solved. So here if we'll see the equation 1, here we can see the in both equation, in first equation 1 also, see this is equation 1 for mass m1, we are getting somewhere x2. See, we are getting x2 here. Check, this is the x2. You just realize by your own. In first equation, it means for mass m1 if you are writing equation, then you are getting x2. Similarly for the second equation for mass m2, if you check, you are getting here x1. See, here you are getting x1, as well as here also you are getting x1. What is the mean of it? So it's actually it's representing that the system which is 2D coupled second order differential equation, and here we can see we can say that expect that the motion of m1 will influence the motion of m2 and vice versa. I mean mass m2, that motion will be influenced by m1, and m1 motion will be influenced by m2. Both are depending, actually both are depending to each other. Means in m1 motion for m1, if you check, it will be influenced by the motion of m2, and just vice versa. That's the mean of it. Okay, now you just segregate this equation. So here you take some common, like x1 common here you can take, here x1 common you can take. So again I will write. Okay, so the final equation for the system, what will be the final equation? If you check, it's nothing but m1 x1 double dot, check x1 we can take common, x1 dot, so it will be plus c1 plus c2, we will have a x1 dot minus then c2 x2 dot, and then we can take x1 common, so plus of k1 plus k2 x1, okay, minus k2 x2 is equal to f1. This is the final equation. I can say this is nothing but equation A. Okay, similarly we can write equation for the second one. So m2 x2, here also we can take common m2 x2 dot, check what common we can take here, minus c2 x1 dot, we have x2 dot we can take common here, so minus c2 in same sequence we have tried. So because it's a second order differential equation, right? So we have to use matrix method, otherwise it will be very difficult for us to solve this equation. C2 plus C3, C2 plus C3, it's x2 dot and then minus k2 x1 minus k2 x1, and you take x3 common, so it will be k2 plus k3 x2 is equal to f2. These two equation we have. Any technique you have learned, suppose in your engineering, you apply the technique and just find out the value. So very easy method is what, because it's a second order differential equation. Okay, so this equation we can solve by the matrix. We have to write this in matrix form and then we'll solve. Then it will be easy for us how we can write. So check it, it's very simple only. We can write the above equation can be written in matrix form. So how we can write? Check, this is the mass. So for the mass m1 and m2, check x1 double dot, and this is also x2 double dot. Dear, I made mistake. Let me get x2 double dot. C2 x1 C2 C3 x2 dot, ठीक है, k2 x1, ठीक है, k2 plus k3 x2. हाँ, this one is correct. So check x1 double dot x2 double dot, what is the mass? m1. So we can say this equation, we can write mass. Okay, mass matrix, we will write mass matrix into, this is what, x double dot, x double dot. Okay, plus check, this is what, c1 c2 x1 double x1 dot, and this is c2 x1 dot. So basically for the x1 dot, or anyway we can write, see, this is for the k, and then again a matrix we will get for the okay. So I will write, because c2 c3 x2 dot we have and c2 x2 dot we have, and here c1 c2 x1 dot we have and c2 x1 dot have. But what is the overall idea? Overall idea is the damping coefficient with x dot. So I can write the damping coefficient means damping coefficient matrix with x dot. So all will come, c1 c2 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 c3, everything will come inside this, because this is the damping matrix. And then we have check stiffness coefficient, spring stiffness k1 k2, this is k2 k3, and this is k2, and it is coefficient is what, with x. So I can say we should write the spring stiffness matrix, and that displacement will come x. Okay, and this will, because it's a force vibrations, we can write force here. And one more thing, because force and all here, even the displacement also, these are the function of time, so we can write the function of time. If you are writing function of time, it's okay, otherwise there is no problem. So but finally what you got, finally you will have mass matrix here, then x double dot plus damping coefficient matrix, we will have x dot plus stiffness matrix, we will have, it is x is equal to force. That's all. This is the final in matrix form. Okay, so and m c k, all you know, it is mass, damping coefficient, and stiffness matrix. Okay, what is m? M is nothing but mass matrix. I'm saying matrix. Okay, what is the c? C is nothing but damping matrix. What is k? K is called okay. Now check how to write mass matrix here. It's very easy. Check mass matrix how you can write. See, here we have mass m1, here we have mass m2, here we have mass m1, here we have mass m2. Okay, so we can write mass matrix like m1, because it's a 2 by 2 matrix. So m1, I will show you how. Uh, this is the mass matrix, just match it here, no? This is the mass matrix, because with x dot we have only mass m1 and m2. Okay, I will show you how it is, and then we'll write the damping coefficient or damping matrix. So what is the damping matrix? C1 plus C2, then minus C2 we have, then minus C2, here we have C2 C3. So all 4 elements will come for the damping matrix. So here check, it is nothing but we have to write from here C1 plus C2 minus C2 minus C2 C2 plus C3. So we can write here C1 plus C2, then minus C2 only, then this is what minus C2 only, and here it should be C2 plus C3. Check it. Okay, C2 plus C3. This is called damping matrix. Coming to the stiffness matrix, see, this is K1 plus K2, this is minus K2, this is minus K2, this is K2 plus K3. So your stiffness matrix will be, check, it will be K1 plus K2 minus K2, then I think it's minus K2, K2 plus K3, minus K2, K2 plus K3. This is the stiffness matrix. How you will write this matrix? It is from the equation 1 and 2. So everything, whatever the matrix you have written using equation 1 and 2, A and B. Okay, this matrix you will be able to write. Now this part is done. This part is done. Now we will talk about the calculation, how to go for the calculation. So if you check both matrices here, it's a 2 by 2 matrix. Okay, and the elements are mass, damping coefficient, and stiffness of the springs. Now even if you check for the both matrix, here we have m1, this is 0, this is 0, this is m2. So we can say, if we'll take the transpose of the mass, I mean if you write the transpose of the mass for this matrix, if you write the transpose of this, then it will be same, because we have m1 0 0 m2. Similarly we can, because it's a symmetric matrix, yes or no, it's a symmetric matrix. And similarly if you check c1 plus c2 minus c2 minus c2 c2 plus c3, so here also if you check the element, it is also a symmetric, right? So we can say, just generally I am saying, it is not useful actually. We can check this is the transpose of this. And similarly here K2, K1 plus K2 minus K3 minus K2 minus K2, K2 plus K3. So here also if you take the transpose of this, you will get the same. So just generally I am saying it is not useful. Useful is this matrix only for the calculation. Okay, anyway, now we have to apply the cases. What are the cases? This is for the force vibration complete equation. Okay, this is the for the force vibration, this complete equation. How to if you better will write the final equation. If you want final equation also, you can write I mean this is the equation. Here they will give the number. Okay, you will have m1 c1 c2, this number you will have. So 2 equation you will get. For that 2 equation you will design this matrix. Okay, so from this matrix you will able to, if they are asking the equivalent mass or equivalent damping coefficient or equivalent stiffness matrix for the system, so you can calculate, you know how to solve the matrix. Second thing, the very special what they are asking in exam, that we have to discuss, because as I told you, the complete force vibration will be very difficult for calculation like you have seen here. So they are not going to ask, they will ask generally free vibration analysis of undamped system. So for the same system I can take the case. What are the case I can take? First, it's free vibration. Okay, it's a free vibration. I'm considering it's a now free vibration analysis of free vibration of an undamped system. Now see, your problem becomes simpler now, and calculation also becomes simpler. So for one day exam for 2 marks, definitely very short calculation problem will be asked to you. It is not for 8 marks, it is not for 6 marks question, it is only for sometimes 1 marks or 2 marks. So very short calculation point of view question will be asked to you, so nothing to worry. If they said free vibration, so that means that forces F1 and F2 both will be 0. So this is sorted now. And now they have said undamped system. So undamped system means what? That means C1 damping coefficient 0, C2 damping coefficient will be 0, C3 damping coefficient will be 0, all three, because it becomes undamped system. Undamped means damping is disregarded, yes or no? Damping is disregarded, so obviously it becomes undamped system. Okay, now again focus the previous problem. So what you will get here, see the same equation. I'm not going to write again that equation. This equation you can check here. This C1 C2 part will be 0, F1 will be 0. Similarly everywhere C2 C3, these parts will be 0. So this equation will be shorted. So again I will write for this what will be the system now. So if you check the system will be, the equation will be, then general solution, general equation first need to write general equation for the free vibration and undamped system. So what will be the general equation now? The general equation here, you just focus here, you make C1 C2 0, F1 0, C2 C3 and F2 you just make it 0. Then what you will get? So you will get here, I will write, you will get M1 X1 double dot plus K1 K2 X1 minus K2 X2 you will get. So you will get plus K1 K2 X1 minus K2 X2 is equal to 0. And another equation you will have M2 X2 dash, I think M2 X2 dash, then C2 C3 then minus K2 X1 you will have. So here you can write M2 X2 double dash, okay, minus K2 X1 plus K2 K3, and this will be obviously X2, and this equation will be, so this is equation number C and this is equation number D. So A and B you have seen, these are the A and B equation. This was for force vibration of a damped system, So this will be the general equation. Okay, this is the general equation for that system. And now your system becomes free vibration and undamped system, then this will be the general equation. Now you can write this into a matrix form. It will be very easy for you to write in matrix form. Okay, if you write the matrix form, then what value you will get? Check. M1 M2 you will have damping coefficient will not be there, only stiffness you will get. So now you can write the matrix form. So only you can say that mass matrix you will have X double dot, okay, plus stiffness matrix you will have k into x is equal to 0. So if you remember, it becomes like mx double dot plus kx. You already have seen mx double dot plus kx. This you have seen for the 1D system. Okay, so in 1D system, first degree of freedom system, only one mass was there and one stiffness, but this is the 2 degree of freedom, so this will be the mass matrix. Okay, so this is for the 1 degree of freedom for free vibration undamped system. Okay, but now for the 2 degree of freedom, this will be the mass matrix plus stiffness matrix is equal to 0. This is for 2 degree of freedom free vibration undamped system. All right, hope this one is very clear. Right, so now we have to go for the solution of this equation. How to go for the solution? So again, I will expand this mass matrix so in two equations. So mass matrix, what, m1 x1 double dot plus k1 plus k2. Okay, I have told you this is the function of time, x1 minus k2 x2 equal to 0. And similarly, this is what m2 x2 double dot minus k2 x1 plus k2 plus k3 x2, and this x1 x2 are the function of time. Okay, x2 equal to 0. So we can assume that x1 of t is nothing but x1 cos omega t plus phi. Phi is the phase angle, already I have discussed. Similarly, we can write x2 function of time, which is nothing but x2 cos omega t plus phi. See, here we have x1 double dot, we have x2 double dot, so we can differentiate this. Okay, we can, x1 dot means we have to differentiate with respect to x1 time. We have to differentiate with respect to time, not x time, with respect to x. We have to differentiate this x1 with respect to time t. Similarly, x2 dot means we have to differentiate this function with respect to time t. Again, if it is x1 double dot, then again you have to differentiate it. So x1 double dot, we have here x2 double dot. So I think that you know, I'm not going to differentiate that directly. I'm going to write here that final equation for this. Hope up here it is very clear. Now all the calculation you can keep here. If you are keeping this value, x1 double dot, x2 double dot, x1 x2, all the value if you keep here, then finally this equation you will get. And better you write this equation. So this equation is nothing but we have, after keeping all the value here, we have final equation. This is nothing but minus m1 w square plus k1 plus k2. Okay, x1 minus k2 x2. This is the cos omega t plus phi equal to 0. Similarly, in second equation also it's minus k2 x1 minus m2 omega square plus k2 plus k3 x2 cos omega t plus phi equal to 0. So how you will get this? See how omega you are getting. See, I told you x1, we have x1 double dot, you have to differentiate, so this omega will come. Okay, you can do that calculation, 2-3 steps you have to do by your own. So finally you will get this. Okay, this equation you will get. But now again you just check cos omega t, maybe cos omega t will be 0 or this will be 0. Okay, because the product is what, 0, both cases the product is what, 0, so you have to take this is equal to 0. So finally what equation you will get? Final equation I'm writing. Final equation we will get, because this product is what, 0, so you take this function as 0 value, so equate it equal to 0. So finally you will get minus m1 omega square plus k1 plus k2 x1 minus k2 x2 is equal to 0. This is the one equation, and here you will get k2 x1. Okay, and it is nothing but this value will be what, m2 omega square plus k2 plus k3 x2 is equal to 0. This is the final equation. Again I am giving this number 1 and 2. Now this equation 1 and 2 you have to solve, and if you solve then you will get the value. So how to solve this? We can take, because we can write in determinant form, we can take the trivial solution of x1 is equal to x2 is equal to 0, which implies that there is no vibration for a non-trivial solution of x1 and x2. So the determinant of coefficient x1 and x2 must be 0. So whatever the coefficient of x1 and x2, will take the determinant and put equal to 0, then you will get the solution. So final, this is the equation, and from this equation we can write for for non-trivial solution of x1 x2 the determinant of coefficient of x1 and x2 must be 0. So take the determinants of the determinant of this coefficient of x. So what is that determinant? Check. Minus m1 omega square x1 is nothing but here, see, it's this was the bracket here, wait, check here, this was the bracket inside the bracket. Okay, now so minus m1 omega square plus k1 plus k2, this is the coefficient of x1, this is the coefficient of x1, and what is the coefficient of x1 here? It is k2, so minus k2, and what is the coefficient of x2? It's a minus k2 here, minus k2, and what is the coefficient of x2? It's minus m2 square, minus m2 omega square plus k2 plus k3. This is the coefficient of x2. Take the determinant of it and make it equal to 0. Now if you know very well how to solve the determinants, So if you solve the determinants simply, so what value you will get, check, I will write here. After solving this determinant, this is what determinant, you made determinant equal to 0. So you know very well how to solve the determinant. So if you solve it, then what value you will get? You will get, I'm just final equation, I'm writing m1 m2. See, m1 m2 omega square, so it will be omega to power 4. Okay, minus, this is nothing but k1 plus k2 m2 here plus k2 plus k3 m1 here omega square plus k1 plus k2 k2 plus k3 minus k2 square. This is in one bracket and this value will be 0. So this is the solution of this determinant. You can do by your own. Finally you will get this. So now for such determinants, I mean, if determinant is there like a1 b1 a2 b2, so you know that how to solve. So I'm not going into that steps, because easily you can do by your own, no? So that steps you have to do. Then finally you will get the value of omega. Check, omega power is what, 4. So how many value of omega you will get? Basically you have to solve this, and this equation, let me write, this equation is called as the characteristics equation. Okay, called frequency equation, or characteristics equation. Okay, characteristics equation. So w1 square and w2 square, 2 roots you will get. Like the equation is what, quadratic equation, ax square plus bx plus c. So what is the solution for quadratic equation? 2 solution, x1 and x2. So similarly, because here omega is the frequency, which is natural frequency, because now you are talking about the free vibration. So for the natural frequency, for natural frequency, omega power is for 4. So how many frequency you will get? 2 natural frequency you will get, omega 1 square and omega 2 square. Again, that value you can calculate, further calculation you can perform. It's very simple. Okay, so all right.